So see, in this bootcamp, we are gonna talk about our data science projects, how to create data science projects, what are the like different steps in data science projects, okay, and by using Python. So before starting data science project using Python webinar, like I just wanted to show you how to download Python, because see, it's a very basic programming language and it's very useful programming language in data science field. Okay, so let's go first to see the how to download Python. Okay, so uh, we are gonna use Python library, Python programming language from, okay, see, just go to the Google, okay, and just search for Anaconda latest version download. Just go to Google and search for Anaconda latest version download and see the first link, which is Anaconda distribution. Okay, click to this link, okay, and see over here you will see the download button, okay, for different operating systems. Okay, accordingly you can download Anaconda. Okay, and in Anaconda, after installation you will see the Jupyter notebook and Spyder. Okay, so we are gonna run our code in Jupyter notebook as well as in Spyder. Okay, so see, like here, okay, after installation you will see one folder like this. Okay, and second thing is that, okay, as in the data science project we have to deploy our model, machine learning model, in Flask, as well as we have so many different deployment environment. Okay, but here we are going to use Flask to deploy our model. Okay, so for that purpose, okay, here we have to download the second thing, which is VS Code. So again, for that purpose, let's search for VS Code download and see this is the first link. Just go here and download the VS Code. Okay, so after this, okay, let's start with our data science project using Python. So before starting this, okay, let me introduce to our about our InfoSec train. Okay, we established in 2016 and now we are one of the finest security and training in institute, and we have a wide range of professional training programs, certification and consulting services in the IT and cybersecurity domain. Okay, and we also have a high quality technical services certification or customized training program curated with professionals of over 15 years of combined experience in the domain. Okay, these all are our endorsements. Okay, so we have a 70 plus pools of trainers. We delivered 200 plus courses as well. We deliver 150 plus corporate trainings and we are offering 200 plus courses. Okay, and we have trained 30,000 professionals. Okay, and we also have a 10 plus valued partner and we also serve in 20 plus countries. Okay, and these all are our trusted clients. Okay, so let's start with our webinar, and today's agenda is introduction to data science. In that we are going to talk about all about data science, what is data science, how to learn data science, why to learn data science, facts and figures about data science and their application, their jobs. Okay, all about data science in this first introduction to data science part. In the second part we are going to talk about introduction to Python. Okay, like basic Python, like how to run the code and all in Jupyter notebook as well as in Spyder. Okay, and lastly we're going to talk about the data science project. So in this webinar we are going to talk about uh, we, uh, we are going to create one data science project for classification purpose and one for regression purpose. So first we will go with the classification, and then next we will go with the regression. Okay, so let's start. So when we talk about data science, so we can simply say that the simplest definition, there is no perfect definition of data science. Okay, but there are a lot of definitions, okay, of data science. We can say that data science is a science of extracting insights from the data. Okay, and because of the data is very exponentially growing, okay, so that's why we are gonna apply data science on the data to extract insights from the data. Okay, so after that, okay, so see, we have so many big e-commerce giants like Amazon, eBay, and Flipkart. Okay, so have you ever wondered how Amazon, eBay, and Flipkart suggest items for you to buy? Okay, they have their recommendation systems. Okay, they are just suggesting items by using your previous history, your buying history. Okay, and on the basis of that, they just suggest items for you to buy. Okay, and this is happened because of data science. Okay, then if we see our Gmail, so in the Gmail we have different folders. First first one are non-spam, which are nothing but the primary, social, and promotions, and the fourth one is nothing but the spam. Or just Gmail just classify our emails into two different categories. First one is spam and non-spam, and then by using non-spam emails, okay, they also apply the same things, okay, for the classification, okay, for just classifying again the non-spam emails into primary, social, and promotions. Okay. So this is also happen because of data science. Okay, and how Netflix predicts the show of your liking. Okay, just because of your liking history, your searching history, what are the different kinds of videos you are watching, okay, in Netflix. So totally depends on that data. Okay, and they are gonna just show you the video which is very much uh, close to your watching history. Okay, so that's why they can say that yes, this video is you can like this video. Okay, so this is a, you can say that the Venn diagram of data science. And data science is basically a combination of mathematics, computer science, and domain expertise. Okay, so as I already told you, data science is the science of extracting insights from the data. Okay, so first we should have the data. Okay, so we will get the data, okay, from of various fields. Okay, we can analyze the data of various fields. Okay, so that's why domain expertise is very much important. Okay, if you know the domain expertise, if you know, like suppose data is from the healthcare domain, so if you know all about that, so then you can go ahead for the data pre-processing, and you can also apply some statistical research, okay, or some statistical analysis on the data. Okay, then mathematics, we all know mathematics is very important because, okay, from starting a first step of any data science projects, okay, we have to collect the data. So for that as well, okay, we require some sampling. Okay, so sampling is nothing but the sub part of mathematics. Okay, so you can say that mathematics and statistics is very much important for data science. Okay, so if you know the mathematics and statistics, then you can able to research some statistical you can do research on the data, okay, by using some statistical analysis or some statistical techniques, and you can even apply machine learning for building the model of predicting a numerical value or predicting a class label. Okay, and third one is computer science. And this is another most important phase of data science project, because in any data science projects we are gonna apply data science by using one of the programming language, and that one of the programming language is nothing but is from the computer science domain. Okay, so in data science, two most common programming languages are there. First one is Python and second one is R. Okay, so we'll talk about this all in depth, okay, in say upcoming part of this session. Okay, so see, and we can say that data science is a science of extracting information in extracting insights from the data, and this one is again the most explained definition of data science. So according to this, I can say that yes, data science is a deep study of massive amount of data. Okay, because nowadays data is too big. Okay, each and every moment data is generating, so that's why we can call the data is nothing but the massive data or the big data. Okay, so so because okay, data is very massive. Okay, and we are applying data science on that. Okay, so from that, okay, we can extract meaningful insights, okay, from any type of data. Okay, you can go and you can apply data science on raw data, structured data and unstructured data as well. Okay, that is processed using the scientific method, different technologies and algorithm. Again, here you can say that some mathematical methods, machine learning, deep learning, some statistical analysis. Okay, different technologies like Python, R, and nowadays we have so many different technologies. Okay, and algorithms. Okay, so in data science, mostly we are gonna solve the problem which are related to data. Okay, like the problems could be a decision making problem, like identifying which email is spam and which is not. Okay, a problem could be a product recommendation problem. Okay, like which movie to watch. And a problem could be the outcome based problem, like who will be the next president of the USA. Okay, so you can answer these questions by using data science. Okay, in short, you can solve any type of problem. Okay, if you have the data related to that question, okay, you can easily go and solve that problem. Okay, so now why to learn data science? Because see, in 90s, okay, there was small amount of data was generating each and every day, because only few people who are just you can say that very successful, or who are very passionate about the internet, only those people are on internet. So that's why data generating process is also a very much uh, low. And you can say that like nowadays we have a excel sheet. Okay, in excel sheet there are like number of rows is around like 1 million. So at that time in excel sheet only 200, 300, 400 entries are there, because of on in like very few people just using internet. Okay, in 90s, but as in 2000, as in 2004 Facebook came, then YouTube in 2005 launch, and then Instagram, then Snapchat, Twitter, LinkedIn, and so many tech giants just launch. So for that reason, more and more people just coming on internet, and that's why data is generating very rapidly. Okay, so they are just, you can say that each and every people just generating uh, around 17 MBs. Okay, and nowadays, okay, 2.5 quintillion bits of data is generating each day. Okay, so 2.5 quintillion bits of data, which means that 2.5 along with the 18 zeros. Okay, so the figure is very big. Okay, so because of big data explosion, okay, the companies wants to analyze that data. Okay, because suppose if we are working at some tech giant, and they are generating data. Okay, so for analyzing data, okay, they wanted to hire people those are just expert in to analyze the data. Okay, so they are just hiring data scientists because they are expert of data. Okay, so that's why we have to learn data science. Okay, then priority of organizations. Okay, because of big data explosion, okay, the company has company just saving their data. Okay, and data is so much big. Okay, so that's why again, okay, they have to like analyze the data, then they will understand the insights from that data, and then they can apply the insight on the business, and they can increase the profit as well as increase the sales. Okay, and data science is also also the core of decision making. Okay, because if you have any problem statement, okay, and you just wanted to solve that problem, so you have to again go with the different data collection part. Okay, and then data pre-processing, data analyzing. Okay, and then you can come up with the insight. Okay, so again, for that reason, you have to learn data science. Okay, and see, data is everywhere. Okay, so that's why data science is the future. And in data science we have multiple job designation. Okay, and even if you have to start your own startup, then also you have to learn data science. Okay, because in startup as well there are a lot of things, okay, you have to create by yourself. Okay, so for that reason, if you know data science, then you can build your startup in a more proper way. Okay, then to optimize business. Okay, again, for that purpose you have to learn data science. Again, this, okay, and see, in very much job hunting see sites. Okay, they are gonna use data science. Okay, and see, in each and every industry we are going to apply data science. So that's why, see, you have to learn data science. Again, cost cutting technology. Okay, you can use data science in operation research to optimize your cost. Okay, and you will get the increased pay. Okay, now how to learn data science. So first, so these are the things you should know. So first thing is that any one programming language, at least one programming language you should know. And in data science, two programming language which are like most of the time, the all the experts and beginners also use this programming language. One is Python, first most useful programming language for data science, and second one is R. Okay, you can even go for a Java, you can even go for a Scala. Okay, and for big data you can go for a Spark, Hive. Okay, then machine learning, second thing is that machine learning. Okay, so in machine learning you will see that we are gonna build the model. Okay, and the model could be a regression model or a classification model or a reinforcement model. Okay, so when we talk about a regression model, which means that we are going to predict a numerical value. Okay, like a prediction of house prices depending on various columns. Okay, like size of the house, uh, the number of rooms in the house, number of bedrooms, number of bathrooms, is there any parking area or not, drainage facility or not, water facility or not, electricity or not, like this. Okay, on the basis of different attributes. Okay, you can go and you can build a model for prediction of house price. So this is the one of the problem of regression. Okay, and you can solve this problem by using machine learning. Second thing is that classification. Classification is nothing but a prediction of any kind of disease in healthcare domain. Okay, again you can implement this in any kind of domain. Okay, but the thing is that the question is to predict, okay, the any class, any discrete value, yes or no type of data is there. Okay, and then on the basis of data, okay, you can go for a building a model of classification, okay, like predicting a liver disease. Okay, then reinforcement learning is advanced machine learning part. And in reinforcement learning we build the model along with collecting a data. Okay, and we just set one agent for collecting the data and analyzing it. Okay, and along with that, that agent is able to just correct the task or not. Okay, so this is nothing but the reinforcement learning. Then data analysis and visualization. So when we talk about data analysis and visualization, so which means that after data collection part, okay, we have to go for a data cleansing, data wrangling, okay, data cleaning, exploratory data analysis, finding best feature, which is nothing but feature engineering. Okay, and then okay, after this, okay, in data analysis you can just find out some insights from the data. Okay, or you can pre-process your data. And in visualizations you can use a different libraries in Python like Matplotlib and Seaborn, and in R you can even use ggplot2 library, which is very much popular library of R programming language. Okay, but in Python most commonly used libraries for data visualizations are nothing but Matplotlib and Seaborn library. Okay, and we have so many libraries, but these two are the most commonly used data visualization library in Python. And when we are analyzing and visualizing the data, which means that we are just finding out the insight, we are transforming the data, we are pre-processing the data. Okay, for which means that we are just pre-processing the data, we are finalizing our data for model building part. Okay, and in model building as well as in data analysis and data visualization we should know mathematics. Okay, we should know the statistics, what is mean, what is median, what is mode, what are the different types of probabilities are there, what are the different types of theorems in probabilities are there. Okay, we should know some amount of linear algebra, some high school level linear algebra, we should know some college level differential calculus. Okay, so this is all about the mathematics, and we are gonna apply this mathematics. Okay, by using mathematics we are gonna build a machine learning model as well as we analyze our data. Okay, and in the visualization to see bar plot. So in statistics, okay, there is one advantage of statistics, we can draw insights of from the visualization. Okay, you can even use you can even use Tableau and Power BI. These are the you can say very best softwares for the data visualization. You can build dashboards as well. Okay, and if you are, if you know mathematics, then it will be great, because see in machine learning there are algorithms, and behind the algorithms there is statistics. Okay, in data analysis if you are transforming the data, let's say if you are see if you have two column, age and expected salary, and the range of age is starting from 0 to let's say 60, and range of expected salaries range will be 0 to let's say 1 lakh. Okay, so can you see the difference in two columns range? So if you want to build model of machine learning on these columns by using these two columns, which means that model is biased toward the expected salary. So for that reason we have to apply data transformation, and in data transformation there are some methods, okay, like normalization and standardization. So these are nothing but the methods of statistics. So if you know the mathematics, then you can easily perform machine learning, data analysis and visualization on your data. Okay, now web scraping is like many times, okay, the you have to start your data science project from scratch, which means that you have to collect your own data. Okay, client only give you the problem and he wants the solution. So for that purpose you have to collect your own data. So there are few libraries in Python. You can use Beautiful Soap as well as your URL lib. Okay, these are the two libraries, as well as there are several softwares as well or apps as well to collect the data from various sources, from various sites. Okay, so by using these libraries, okay, you can do the web scraping. Okay, you can collect the data. Okay, as well as there are various different ways to collect the data. Okay, like you can collect the data by using survey. You can use a developer account to collect your data from LinkedIn, from Twitter, from email, like this. Okay, as well as, okay, you can download the data from open source like Kaggle, like uh, open data. Okay, there are so many websites which are just providing a free data sets. Okay, so you can go and you can create your own data science projects, okay, without collecting the data by using these websites. And lastly, the integrated development environment. Okay, like you have the data, you know the mathematics, you know machine learning, you know data analysis and visualization. Okay, and you know, yes, you can easily go with a Python programming language. Okay, but see, from where you can just use Python. Okay, so these are the Spyder, Jupyter Notebook, PyCharm are nothing but the IDE for just using Python. Okay, so that's how you can learn data science, and these are the basic, you can say that these are the basic things for data science. Okay, to start for data science. Okay, now let's talk about the scope of data science. So when we say scope of data science, so just go and search for the sexiest job of 21st century. So then Google will show you that data scientist is the sexiest job of 21st century. Okay, and this is a Harvard Business Review. Okay, and according to Glassdoor, data science is the topmost profession. Okay, and data scientists are the highly paid professionals in the world. And as we know, data is exponentially growing, which means that there is there is always be a scope of data science, okay, in upcoming years too. Okay, there is no saturation of data science. Okay, so now let's talk about the jobs in data science. The first and most common job in data science is nothing but the data scientist. Data scientists who can build the model, data scientists who can collect the data, data scientists who can process the data, data scientists who can do all the steps. Okay, starting from scratch, starting from data collection to model deployment by using various interfaces like Flask, Heroku, as well as AWS, Azure, Google Cloud Platform. Okay, like this. Then second job is nothing but data engineer. Data engineer is relevant to a data warehousing who can just collecting the data, who can manage data, who pre-process data, okay, who transform data, okay. Data architect is also similar kind of data engineer job, okay. Then big data engineer. Now when we say big data, which means that, okay, see, there is a difference between a normal data and big data, okay. Big data is nothing but each and every second data is generating, okay. Each and every second we have to analyze the data, okay. So if the data is generating each and every second, so this is nothing but a big data, okay. We don't know the, like, how much data is generating each and every second, okay. We don't know the total number of rows, because every second number of rows are updating, okay. Every second number of images are increasing, every second number of videos are increasing, okay. Like each minute on YouTube, 100 plus hours of videos were uploaded on YouTube, okay. So we can say that yes, uh, YouTube is generating big data, because each and every second data is generating on YouTube, okay. Then business analytics specialist, okay. So this position is very much related to a analytics kind of role, okay. And analytics means like a, just to find out the insights from the data, okay, for the business, for the company, for a specific part, okay. Now data visualization developer, okay. So data visualization developers and business intelligence engineers are nothing but the two most common positions, okay. Because here in this position we have to build the dashboards, and then we have to go and we have to tell the story by using dashboards, okay. Then statistician who interpret the data, okay, which means that the statistician applies different statistical analysis, different methods on the data for prediction purpose, for forecasting purpose, for finding insights from the data, as well as for just interpreting the one plot as well, okay. Now data analyst is nothing but a, some, just handle the data and do the data analysis stuff, okay, to analyze the data, okay. Same as business analyst. Machine learning engineer is very much specific to a machine learning part, okay. As we know, in data science, machine learning is not only, it's not the one, you can say that one domain. There are various domains in in data science, and machine learning engineer is one of them, okay. So machine learning engineer, which means the person that build machine learning model, okay. The person is expert in machine learning. Same as deep learning is again the subset of machine learning. And deep learning, you can say that, it totally depends on the neural network, which are black box techniques, okay. And it's the most difficult part of artificial intelligence as well, because machine learning and deep learning are the subset of artificial intelligence. Then BI solution architect, which is very much similar to business intelligence engineer, and analytics manager who can manage analytics team, okay. So these are the very few jobs, okay. Now again, the job position is totally depends on the companies, okay. In few companies there are only the analysts, in few companies there are only the data scientists. So this is totally depends on the company, okay. What are the different kinds of position, okay, they are opening. Now let's talk about the facts about data science. So an AI generated text, means artificial intelligence generated text prediction model, was trained to write a Harry Potter novel. An AI powered software was created that could predict the results of the Oscars with 90% accuracy. So you see that by using this data science, okay, by applying artificial intelligence, okay, on the data, so with that we can solve any kind of problem. The amount of marketing budget firms allocate towards marketing analytics increased by 198% in 2020. So you see the increment percentage is around 200%. Okay, so you see the scope of data science. The average salary for a data scientist is $1 lakh, okay, according to the Bureau of Labor Statistics, and that of an analyst is $70,000. Okay, 99% of organizations are actively investing in data transformation initiatives. So see, nowadays most of the organization are instead interested in data analysis. Okay, they have to analyze their data to find out the insights from the data. Now, like, there are a lot of facts about the data science, and these are the few most important facts about the data science. The UK's National Health Service has estimated that by 2040 it will require 90% of its staff base to be data literate. Effective data storing is one of the most powerful skills a data scientist can learn. Okay, so like say in the like bio section, okay, on LinkedIn, most of the data scientists just written I'm a storyteller, data storyteller. Okay, because storytelling from the data is very much important in this data science field. Okay, the number of data analysts has more than doubled since 2010. Okay, so as data is generating exponentially, so which means that companies will hire a number of the like data science or data analyst positions. Okay, now let's talk about the steps of data science projects, and then after this immediately we'll go for a practical problem. Okay, practical use case of data science projects, which is nothing but a prediction of diabetes disease, and we can deploy this in Flask. So first is nothing but the problem statement. We should know the problem statement. If we know the problem statement, then we can go and we can solve that problem statement. Okay, now if we talk about this a data collection, okay, so if we know a problem statement, then we can simply go for a data collection. Okay, and there are different kinds of data collection steps are there. You can collect the data by using surveys. Okay, you can even go for a some poll, okay, to collect the data. Okay, and you can collect the data by using various sources, like by using some web scraping you can collect your data. Okay, you can say that in short, you can say that data science, data collection is the process of gathering and measuring information on targeted variables of interest in an organized system. Okay, like few data collection methods are nothing but the a government institution. Okay, then from Kaggle you can download the data, or company database server. Okay, from company way database server you can collect the data, as well as you can collect your self data. Okay, as well. Now after that, third step is nothing but the data cleaning. So after data collection, okay, first we know the problem, we collect the data accordingly, and then the third step is nothing but the data cleaning. So around 80% of your time will spend on cleaning data only. Okay, you cannot overlook this step, because as we know, data scientists just apply their 80% of time, okay, on data cleaning, and only 20% of time in other steps. So cleaning your data is a process of ensuring your data is in the correct format, consistent, and errors are identified and dealt with appropriately. Okay, like in data cleaning, okay, you can remove duplicate data, you can remove irrelevant observation, you can go and find out the missing values, and you can input or replace those missing values by using mean, median, mode. Okay, we'll talk about this in the practical part, okay, in the coding part. Okay, then reformat data types. Okay, like most of the time, your columns of your data maybe just are from the a categorical type or a boolean, numeric, or a date time. Like again, this is nothing but a same. Okay, so I like few creators who can go with a data preparation, few creators who can go with a data cleansing, few go with a data wrangling, like this. Okay, but this all are nothing but the same, which is nothing but a data cleaning. Okay,
Sure,
and
thank you.
you
Yeah.
and in data collection, okay, lastly you can validate your data. Okay, then in the fourth step, which is exploratory data analysis, you can apply statistics. Okay, you can just apply several statistical analysis on that, like a hypothesis testing. Okay, for checking few columns are significant or not. Okay, like this you can go for a correlation analysis. Okay, or you can go for a small visualization. Okay, so these all are nothing but a exploratory data analysis. Okay, so like there are different types of exploratory data analysis. Okay, depends on the data. Okay, so if you wanna go with a univariate non-graphical, so which means that you have a one column and you are just finding out a mean, median, mode. Okay, or you can go and you can find out the outliers. Okay, outliers are nothing but the extreme values. Let's say if you have a data like in between 0 to 10, and there is one observation in that data which is 100, so that 100 is nothing but the outlier, because the most common range of that data is 0 to 10, but the one data point is 100, so that is nothing but the outlier. Then univariate graphical. Okay, which means that, okay, if you have the data which is univariate, means one variable, one column you have, and you are just creating histogram, box plot, and different kinds of the graphical techniques. You can apply different kinds of graphical techniques on the single column. Okay, and if you have several columns in your data, then you can go with a correlation. You can create a scatter plot. Okay, you can create a bar plot, stack bar plot. Okay, there are multiple statistical techniques you can apply on your data. Okay, so this is nothing but the exploratory data analysis. So in the real life, when you are applying this all the steps, okay, which means that, okay, so there is no specific kind of thing is there. Okay, uh, like when you are doing data cleaning, so after that, okay, you can do a exploratory data analysis. In data cleaning itself, you can apply exploratory data analysis on your data. Okay, then after finalizing your data, okay, you can go for a feature engineering. Now feature engineering, there are different types of feature engineering. Is feature engineering, in short, is nothing but just finding out the useful features. Okay, which means that if we have 1000 features in our data, 1000 columns in our data, and so can we go with a 1000 column? Yes, we can go with the 1000 column for further analysis, but for that, okay, we should have a updated system But what if we don't have updated system? So then we can apply feature engineering, okay, to find out the most useful or most important features of that data, okay. And then we can go with those only, those most important features, okay, for the further steps. Then then model building. So after getting the best features, okay, then we can go and we can build the model by using machine learning, okay. So as we know, there are three three main types of machine learning problems, okay. First one is a supervised problem, okay. In supervised learning, you will see that there is two kinds of problem: regression and classification. in unsur in unsupervised learning, you will see that there is a data dimensionality reduction, which is also one of the feature engineering technique. Now there is another clustering, okay. You can create groups of your data if your data is too big, or if you have to apply a one kind or a one, you can say that one offer on a particular place, then you can collect the data of that particular place only. So you can say that yes, this is again the clustering, okay. And lastly, after building the model, just finding out the best model from various model, because in regression, in classification, in clustering, in data dimensionality reduction, we have so many algorithms, okay. In regression, we have, you can imagine, okay, like we can 10 plus algorithms, okay, which are, you can say that beginner level algorithms, okay. You can even go for advanced regression techniques, okay. In classification, again we have 15 or 20 plus algorithms, okay. These again the basic beginner level algorithms, okay. Then in clustering as well, we have so many algorithms. In data dimensionality reduction process, we have so many algorithms, okay. So for finding out the best algorithm, for finding out the best accuracy for our data set, okay, we can go for a different evaluation matrix, okay. We'll explain all these matrix, okay, in the coding part, then you will understand. So after finding out the best model, we can use that particular model for deployment, okay, for our practical use, okay. Because now first we have a problem statement, we solve the problem, okay. We build the model of accuracy around 90%, let's say, and now we are deploying this model, okay, on the web, okay. And now all the people can use our model, okay. All the people can use our model, okay, to solve the same kind of problem, okay, like the prediction of disease. So if we have all the information about the, like the information which we ask, and if we put all the information and click to the predict button, then we'll definitely see the person will have a diabetic or not, okay. Means person is from a diabetic or not, means the normal person, okay. So like this we can create our end-to-end data science projects, okay. And lastly, communication, which means we can explain all about our data science project, okay. Let's say we create a web app by using Flask, okay. Then we should know all about that web app, okay. We should know all about the domain, okay. We should know all about the data. Then we can able to explain, we can communicate with others, okay. So again, this step is again the very much important, okay. So let's start with the our coding part. And see, coding part is again a very a important part, and it is very interesting. You can say that very much similar to a data collection, sorry, data cleaning. Because in by using pandas library in Python, you can clean your data. Okay, you can do several operations or data. You can merge your data. Okay, if you have number of data set, then you can merge your data. You can drop some data. So this kind of work is nothing but the data wrangling. So let's talk about our data science project. So this is the first data science project, which is nothing but a predicting diabetes using machine learning. So this is our business problem. Okay, we have the data of around 9 features. Okay, and total we have the 768 observations, and I downloaded this data from Kaggle. Okay, and the data is collected from the National Institute of Diabetes and Digestive and Kidney Disease. Okay, so data is again a very important data set in healthcare domain. Okay, so now here we have to build the model of machine learning on this diabetes, for this diabetes prediction. So now we have the 9 features. First feature is nothing but the pregnancies, like the number of times pregnant, then glucose and its explanation, blood pressure, skin thickness, insulin, BMI, diabetes predictive function, age, and outcome. Outcome 0 means no diabetes, 1 means diabetes. Okay, so this is all about the data. Okay, the short introduction and overview about the data. Okay, so after this, let's go and import the libraries. Okay, so we can go and clear all the outputs. Okay, then we can able to go for our project. Okay, so see here, first library is nothing but a NumPy library, and see this is a Jupyter notebook, because like I want like I didn't talk about a Jupyter notebook and Spyder. So see, this is a Jupyter notebook framework, and after installing Anaconda, okay, you will see the Jupyter notebook here. Okay, Jupyter notebook and Spyder. Okay, if you install this, so again you will get the first Anaconda navigator. Okay, you can go here in Anaconda navigator, and in this Anaconda navigator we have so many interfaces like Jupyter notebook, Spyder, we have Orange, we have PyCharm. Okay, but these two are the most common, so that's why, okay, I'm using this Jupyter notebook. And running code in Jupyter notebook is very much easy. Okay, you can just see this is a one cell, okay, which is a coding cell, and you can run your coding cell from here. Okay, you can even run your coding cell by using control plus enter, as well as by using a control plus shift. Okay, so if you go for a this different runs, okay, then you can able to run this cell. Okay, this is a whole cell. Okay, and this is a one line of code. Okay, and you can type any line of code in one cell, and you can run all the code of this cell, okay, in a one go. Okay, so again, this is a beauty of Jupyter notebook. Okay, and Jupyter notebook gives you a different types of cells. Okay, first as a coding, markdown are nothing but these cells. Okay, this cell is nothing but the markdown cell. Okay, you can write the description. Okay, so you can write explanation about your code. Okay, and in coding cell itself, if you wanted to write something, okay, which is comment, okay, so you can use the hash. Okay, so which means that Python just ignore this line. Okay, if you use hash, so after this Python will ignore this. So you can write your comment, okay, in the coding cell, before the code, not before the code, above the code, after the code, and below the code as well. Okay, so this is totally depends on you. Okay, and you can add the cell. Okay, see, like this you can add the new cell, you can cut the cell. Okay, see, you can even copy the cell. Okay, and you can paste the cell. Okay, so it totally depends on you. Like, see, there are a lot of simple buttons. Okay, you can just uh, shift the cell, okay, above and below. Okay, you can run, you can stop, interrupt the cell. Okay, you can restart the kernel, okay, and you can here after restarting the kernel you can rerun the whole notebook too, okay, by using one button, which is this, okay. And again, this is all about the like kernel. You can go again the interrupt, which is this same, okay, restart, okay, you can restart the kernel, you can restart and clear output, okay. This is all about the all the information about the Jupyter notebook. In help you can learn Jupyter notebook as well as Python, okay. See here Python reference, okay, the NumPy, Scikit, Matplotlib, SymPy, Pandas references are there. You can go and you can learn these all the libraries, because Pandas, NumPy, Matplotlib, these libraries are the very important libraries, okay. So see, basically we are going to use this library. First one is NumPy library for statistical analysis, for linear algebra, for creating n-dimensional arrays. We are going to use NumPy library, okay. Second thing is that you can uh, use NumPy library again with the along with the pandas too, for a data wrangling, okay. Then we can use pandas for data wrangling, okay. This is a very famous library of Python for data analysis, okay, data wrangling, data cleaning, okay, as well as reading your data, okay. Then Seaborn library, Seaborn and Matplotlib, these two library are for the data visualization library, okay. Specifically Matplotlib library is a very important library of in Python, okay, for a data visualization. So let's go and run this cell, okay. Okay, so after running this cell, okay, so this cell executed. So now we just imported these four libraries, okay, which are important for our analysis for a data pre-processing and data visualization purpose, okay. Now see here again, after importing pandas library, we are going to use pandas library to read the data, okay, and we are going to use a read underscore csv method to read the diabetes data, which is in csv format, okay. You can see our data over here, okay. See, this is a diabetes data, okay, and in this data, okay, see, this is a, you can say that again the very important part of Jupyter notebook is this, okay. So see, this is okay, from here you can just open all the Jupyter notebook files, okay. So this is a one Jupyter notebook file which is in IPYNB format, okay, and I'm using the same file, okay, and in the same folder I have the data which is diabetes.csv, okay. So see, this is here my data. Now there is no need to again write the path over here, okay. But if you are working in Spyder, okay, then you should need to write the path. Otherwise you should need to change your directories path, okay, then only you can read your data, okay. So that's the beauty of Jupyter notebook. So let's go and read the data, okay. So see, in one go we just read our data. After this, see, this is a head method, and with this method we will see the first 5 data points of our data, okay. So this is how our data looks like, okay. We can use the same head method to see the any number of line in our data, okay. Or you can use a tell method, okay, to see the data from below, from down, okay. So here you can see the data index start from a 0, but if you use tell method here, then the data index start from the down, okay, to the very last. So see here, total we have 768 data points. Okay, means we will see the last 6 data points. Okay, if we go with a head method. Okay, instead of instead of head method, if we use tail method, then we can see the last 6 data points. Then see, this is a SNS, which means we are gonna use the Seaborn library. Okay, here we are using a Seaborn library and we are creating a count plot. Count plot of what? Outcome column. Okay, outcome column is nothing but the, in the data, see here we have the 9 columns. Okay, first 8 columns are nothing but the input column. Why input column? Because we are gonna create the model, machine learning model, by using these 8 column for predicting this last column. Okay, for predicting this outcome. And now this outcome is of only two types, 0 and 1. Okay, so this is a class, so we can say that we have to build a classification model. Okay, so let's go and just select the column name and the data, which is data frame, our df. Okay, and let's run this. Okay, see, this is nothing but the count plot. Okay, count plot is gives you a visualization, okay, in a bar chart. Okay, so see, this is a 1 bar for class 0, 1 bar for class 1. You can say that yes, here number of data points belongs to class 0 is high. Okay, means no diabetic patients are high and diabetic patients are less. Okay, because in like when we go for checking diabetes, okay, so most of the time if we are healthy, so which means that yes, we don't have any diabetes. Okay, so that's why, see, the no diabetes patients are high. Okay, we can see the numbers as well by using value counts. Okay, so see, data points, 500 data points belongs to the class 0 and the 268 data points belongs to the class 1. Okay, so this is how you can go and you can check the value counts, okay, of your data. Okay, from this you can decide whether your data is balanced or not. Okay, because here the class 0 is around it quite double. Okay, it's around double data points as compared to class 1, which means that this data is the imbalanced data. Okay, we can see the shape of our data set, and the shape is nothing but the number of rows are nothing but the 768, and there are 9 columns. Okay, you can see the, you can go and check the data types. Now these are nothing but the, this all are nothing but the, you can say that the data cleaning. Okay, because here first step is to understand the data. Okay, first we have the data, first we should, like, I need to understand the data, then I can go for the data cleaning part. Okay, so see, data types all are nothing but the numerical values. Some are integers, some are floating points are also nothing but the integers, the numerical values. So see here, this 33.6 is nothing but the floating, and 35 is nothing but the integer, int. Okay, now we can, now from here we are just starting a data cleaning. Okay, so in data cleaning we know that we can go and we can just find out the missing values. So now here we are just checking the, is there any missing value in our data. So see, in our data, okay, there is no missing values. Okay, in our data there is no missing values. Now we have to check in our data, is there any irrelevant data or not. Okay, because sometimes if we don't have the data, so the data entry operators just use 0 to fill the cell. Okay, so that could be the problematic situation, because when we say glucose is 0 in our body, which means that Yes, it's irrelevant data. Blood pressure is 0, irrelevant data. Skin thickness is 0, which means no skin. Okay, so this is nothing but the irrelevant data or the data error. Okay, so we have to fix that data. Okay, so after this, okay, for checking, so first we check, is there any missing values? So here we see there is no missing values in our data. Now we'll just go and describe the data. Okay, now in the data description you will see that, okay, we just find out the count, mean, standard deviation, minimum value, quartiles, okay, 25th quartile, median, 75th quartile, and maximum value. Okay, so now here you can see that in the pregnancies, okay, the minimum value starts from 0 up to 17, but in glucose minimum value starts from 0 and the maximum value is 199. So see the difference in range. Okay, in blood pressure minimum value start from 0 and see the range 122. Okay, so like this, here you can see that in insulin minimum insulin value is 0 and maximum is 846. Okay, so can you able to see the difference in ranges of these individual columns? So I can say that yes. Okay, you can cross check this by using standard deviation. Standard deviation is just the measurement or unit of checking a variation. Okay, for pregnancies there is a standard deviation 3.36. For glucose there is a standard deviation 31. So you see the change in variation. Okay, see the change in variation 19, 15, 115, 7. Okay, zero point 0.3, 11, like this. Okay, so here in description we have to check the all the values, we have to compare all the values of these columns only, not the last column, because last column is the output column. Okay, we are gonna apply any transformation and anything, okay, any cleaning part on these columns only, not this column, because this is the output column, and we are gonna build the model for predicting this outcome column. Okay, now we can also see the average. Okay, mean is nothing but the average. Okay, we can see the median value. Okay, like this we have so many different statistics which are descriptive statistics. Okay, now we can go and we can see the correlation. Okay, so in most of the machine learning algorithms, not all, in like in logistic regression, they there are few assumptions. Okay, and one of the assumption is the input columns, which means the first 8 columns should be independent. Okay, and correlation is a one method of statistics. Okay, by with this correlation we can easily find out, is there any relationship between two columns or more than two columns. Okay, so by using df.core method, okay, here we just find out the correlation between the columns. Okay, so see, you can say that the all the diagonal values are nothing but the one, because yes, if we say is the correlation between me and myself is always one. So like this, correlation between pregnancies and pregnancies is one. Okay, so the secondly, correlation between glucose and pregnancies is 0.12. Okay, now let me tell you that correlation range is between -1 to +1. Okay, correlation range is between -1 to +1. Okay, is between, so yeah, I don't know what is the problem. It's not working here, so let me clear. Okay, we can go and use this whiteboard as well, because see, we should know the correlation, then we can understand the correlation matrix and these figures. Okay. Okay. So see, when we talk about the correlation, so the range of correlation is between -1 to +1. Okay, +1. And when we say -1 is a strong negative correlation, okay, is a strong negative correlation, +1 is a strong positive correlation. Okay, and in between -1 to +1, we can say that yes, there is some correlation, but the correlation which is close to zero, okay, let's say minus zero point 0.5, okay, to zero point 0.5, we can say that there is poor correlation. Okay, so if the correlation is lies between in this range, so we can say that yes, there is a poor correlation. Okay, in between -5 to minus zero point 0.5 to plus zero point 0.5. Okay, if we say the correlation in between -1 to, let's say, minus 0.7, so there is a strong correlation, as well as a 0.7 to 1. So it's this threshold value, it's totally depends on you. You can, it's a subjective choice for choosing this, so these values of correlation, for just saying that there is a strong correlation, moderate correlation, or poor correlation. If we say zero value of the correlation, which means no correlation. Okay, which means no correlation. Okay, so let's come to our slides. Okay, no, not here. Okay, so here, when we talk about the correlation between glucose and pregnancies, so see, the correlation is very much close to zero. Okay, so we can say that yes, there is no correlation between pregnancies and glucose. Okay, and we are gonna check the correlation between these all 8 columns only. Okay, so you can use either lower triangular matrix or upper triangular matrix, because this matrix, this correlation matrix, is a symmetric matrix. Okay, and you can go and you can see, because most of the correlation, okay, values are just less than zero point 0.5. Okay, so see, if here we have only 8 columns, okay, to check the correlation. Okay, what if we have a lot of columns? So then, okay, we have on another trick, okay, to just see the correlation. Okay, see the highest correlation, see the lowest correlation. Okay, so for that reason, okay, just go with this cell, okay, run this and see the correlation map. This is also called as heat map. Okay, and see here, you can see that the correlation value, okay, in this correlation matrix start from minus 0.1 to zero point 0.5. So for minus 0.1, the color is this, and zero point 0.5 color is this. So you will see that yes, all the correlations are less than zero point 0.5. Okay, only two correlation are equal to zero point 0.5. Okay, but again 0.5 is, I can say that this is a poor correlation. Okay, because this is on the border. Okay, we can't say that yes, this correlation is either a like a strong correlation or a strong positive or negative correlation. So we can't say like that. Okay, because the value of correlation is 0.5. Okay, so now from this correlation matrix, from this correlation map, we can easily say that yes, now we can go with our further analysis. Okay, so first thing is that we check, is there any missing value or not? There is no missing value. Correlation means a relationship between the input columns are, you can say that, very negligible, so we can say that there is no correlation. Okay, or even you can go and you can see the pair plot. Now the pair plot gives you a visualization of each and every column by using a scatter plot. Okay, and scatter plot is another way of checking is there any relationship between two columns which are continuous one. Okay, so by using seaborn library, okay, dot pair plot, you can go and you can check these things. Okay, so see, I just divided this data point. So see, this is my first scatter plot, this is second, like this we have so many scatter plot, we have a matrix of scatter plot. Okay, and I splitted our data into outcomes. Okay, the pink data points are nothing but the 0 and the green data points are nothing but the 1. Okay, so here you can see the scatter plot. So scatter plot like this, which is a very randomly shape, random in shape, so I can say that this scatter plot are showing a no correlation. Here also you can say that yes, this is again a very random shape, no correlation. Okay, again this is a random shape, no correlation, no correlation, like this. Okay, so here, okay, we can say that almost all columns are showing no correlation. Okay, another thing is to go and check the data distribution. Okay, data distribution by using this density plots. These are not, these diagonal plots are nothing but the density plots. Okay, so for this, okay, you have to explore what density plot is. Okay, density is nothing but a distribution of the data, and you can create the plot of this density. Okay, so this here you can see the two density plots, okay, in a one plot. Okay, which means that you can easily compare the class 1 data points, data from class 1, data from class 0, like this. Okay, you can easily find out the difference between class 1 and class 0, which means that, so here you will see that, see, the class 0 data points are just taking higher values of pregnancies, and class 0 are taking the lower values of the pregnancies. Okay, like this. Here also you can easily split this. Okay, you can say that class 1, class 0 are just taking the higher glucose values, uh, class 0 taking the higher glucose value, class 1 taking the lower glucose value, because output, okay, these are the output. Okay, the this pink color shows a class 0 data points, and the green data point shows a class 1 data points. Okay, so like this you can analyze this, you can find out the insight whether this particular column, whether each column is significant for our analysis or not. Okay, for our model building or not. Okay, so after this, after just finding out the association between the columns which are input columns, or the associate or the relationship between the input column, we can say that yes, there is no relationship between these input columns. Okay, now after that, okay, we have to find out the number of zeros, okay, number of zero values from each and every column. So first we know, first column is nothing but the pregnancy column. So we can understand, if the value of pregnancy is 0, which means that no pregnancies. So we can understand this thing. But if we say glucose value is 0, so this is the, like, the irrelevant. Okay, this is the not peerable data. Okay, so we have to just find out those data which is not correct in our data set, and we have to replace that data, or we can just remove that data, we just drop that data. Okay, so for that reason, okay, we just go and we just find out the total zeros from each and every column, excluding our outcome column and the first column, which is pregnancy column. So now we are gonna just find out the number of zeros. Okay, those are in remaining column starting from glucose to age. So let's run this. So in glucose column, total zero values are nothing but 5. In blood pressure, total zero values are 35, like this. Okay, total we have the values. Now we got the all the zero values which are there in the columns, and we can say that now we have to drop this column, either drop this column, and we have, or we have to fill those column with suitable value. Okay, so basically this is again the very important part. Okay, because when we say if we have to fill the missing value, or if you have to fill the data instead of any incorrect data or outlier or anything, okay, if we have to fill the data, okay, so then we can use either mean, okay, we can use mean, we can use median, okay, or even we can use mode. Okay, so there are different choices of using these three different arithmetic means. Okay, the first thing is that, okay, we are going to use mean when the column is numeric. Okay, when the column is numeric, then we can only use the mean. Okay, but in the numeric column we have to check is there any outlier or not. So if there is no outlier, so then only we can go for the mean, okay, for imputation. Okay, so we can replace any, we can replace any missing value. Okay, we can replace any missing value. Okay, or we can replace the zero value, we can replace outlier, okay, by this. Okay, so it depends on us whether we have to replace or just drop the data. Okay, second thing is that median is nothing but the middlemost value. Okay, so we are gonna use median to replace our irrelevant data when our data is numeric. Okay, and there are outliers present in our data. Okay, so let me tell you the difference between this. Okay, why we use median, why we use mean. Okay, so let's say if we have the data which is 1 2 3 4 5. Okay, okay, let's say 6, and we have the data which is 100. Okay, so the mean of this is influenced, is definitely influenced by this value. Okay, because we know that total of this is very less. Okay, and if we add these, okay, 100 value in this total, then absolutely mean is just biased, totally we can influence by this 100 value. Okay, but instead of this, if we use median here, so in that case, then median just use 3 value. Okay, or just this these are the 6 numbers. Okay, so just because this is the outlier, so that's why median is nothing but the 3.5 here, but the mean is quite high. Okay, because how we can find the mean, sum of these numbers divided by the total number of, or the length. Okay, total number of numbers. Okay, so this is how we just calculate the mean and median. Okay, and we are going to use mean and median on different situations. Okay, so our data is numeric. Okay, so first condition is satisfied. Okay, so we can even use mean or median. Okay, now we have to check is there any outlier in our data or not. So then we can go and find out the we can replace those zero values by mean, either mean or median. And when our data is discrete or the categorical or text data, okay, in simple format text data or 0 1 data like this. Okay, yes no type of data, true false type of data, means there are few similar kind of data. Okay, like in one column there are only 4 values which are common, so we can say that this is a categorical data. So in that case you can use mode. Mode is nothing but the most frequent value in the column, most frequent value in the data. So you can replace any value by mode. Okay, but that value should be irrelevant, not correct value. Okay, because these are the very basic things. Okay, if we know these things, then only we can go for the data science projects. Okay, and this is a part of statistics. Okay, so that's why learning statistics is very much important to create any data science project. Okay, actually there is no a see there is no test for checking the outlier, but you can visualize the outlier. Is there any outlier or not in the data? Okay, so you can't test the out you can use a test to detect outlier, but you can use the simple box plot to just find out the out to just detect the outlier in the column. Okay, let me show you. So see here. Okay, so we are gonna create out box plot here. Okay, for checking. Okay, so before that, okay, let me show you this. Okay, number of data points, okay, those are zeros. Okay, which are from glucose column. Okay, and here we are just comparing how many zero glucose value are from each class. Okay, either 1 or 0. Okay, so you can just find out this. Okay, you can extract the only subset of the data which you want. Okay, by using this. Okay, by using this line of code. See df. Okay, here I'm using df. Okay, and I want the specific data. Okay, in glucose column those values are 0. I just want to see those data points. Okay, so see, so only 5 rows are there. Okay, in glucose column which are showing is 0 values. Okay, so how many are from class 0 and how many are from class 1? That's we are going to find out in the upcoming cells. Okay, so see, this is for the glucose column, this is for the blood pressure, this is for the skin thickness, this is for the insulin, and this is for the BMI. Okay, why we are doing this? Because okay, we know that the data distribution, see, this is the density plot for class 0. This pink is nothing but the density plot for class 0, which means range of this insulin column for class 0 values are this. Okay, this is a high range, but the range of this class 1 is low. Okay, range of class 1 is low. So that's why I'm gonna just split this into 2 different classes, like split class wise, and then replace zeros. Okay, replace zeros. Okay, so here, before that, okay, first we have to replace zeros. First we have to replace zeros by nan values, which means missing values. Okay, so here I just created a one simple definition, one simple function of replace 0. Okay, here I am providing it my data frame. Okay, here I am using a just copying a data frame. Okay, and just storing as a nan. Okay, means df dot nan means in data frame consists of missing values, nan values. Okay, these are my columns. Okay, because in this, okay, in these columns, okay, we have to just drop the 0 values, and not drop, just replace the 0 values by nan. And here we are gonna replace 0 by nan. Okay, and return the data frame. Okay, understood? And here we are just applying this function on our data frame. So let's run this. Okay, and see the 2 rows by using the head method. So see here in the insulin, here we can see the 2 nan values. Now in the data we have the missing values. Okay, so we can check these missing values by using isNA. isNA means is there any nan value present in our data or not. Okay, so here specifically we are checking in glucose column nan values. Okay, so see, total 5 nan values are there as we know. Okay, see here in glucose column how many zeros? 5 zeros. So we just transform these zeros into nan missing values. Okay, now here you can see that here I'm gonna find out the median. Okay, I'm gonna find out the median because here you will see that. Okay, wait. Okay, okay, so in upcoming slide, in upcoming code, okay, you will see the box plot, then I'll explain this. Okay, so here I'm just creating a one function which is a median function. Okay, now see we have a different columns in our data. Okay, so we have to find out the median, but in columns as well the data points are from class 0 and class 1. So that's why here you will see that. Okay, I'm just finding out the median value for each class, for class 0 and for class 1. So for this I'm just writing this 3 line of code, and lastly I'm just in the return I want the median for column which is from class 0 and which is from class 1. Okay, so let's create a function which is a find median. Okay, and here let's try how the find median find out the median. So here we got the median value. Okay, for class 0 and for class 1, see the difference of median value for each class, for class 0 and for class 1. See the difference. First, for class 1 median is 107, for class 0 median is 140. Okay, so there is a quite difference. Okay, so here now after this we have the data df nan. Okay, missing value data means in the data frame we have the missing values. So here we are gonna see, just find out the missing values by using isNA method and sum the all the missing values column wise. Okay, so let's run this. So see, in the pregnancies there are 0 missing values. Okay, in the glucose there are 5 missing values. These are these missing values which are same as the zero values. We can say that the zero values. Now here instead of checking zero values we are gonna find the missing values. Okay, so that's the difference here. And here we are replacing all the missing values, all the nan values, all the null values. So see, for one term we have several names. Okay, null value, nan value, missing value. Okay, so in data science, okay, see data wrangling, data cleaning, data cleansing, okay, are nothing but the, you can say that the similar names. Okay, so for one term there are many names. Okay, so here in this function of replace null, okay, here we have to import data frame and the variable name which is also called as column name or the feature. Okay, now here this is a median tuple. Okay, find median, we are gonna use this find median function which is this. Okay, over here. Okay, and we are gonna just find out the median for class 0, median for class 1. Okay, now after finding out the median for class 0 and class 1, we know that the how many data points, okay, in class 0, okay, which are null. So just replace this by variance. Okay, by that in that particular variable column replace this by where 0 which is median for class 0, and the same for median for class 1. Okay, so we are doing the same thing over here as well. Okay, and in the last return the all the is null. Okay, like this return this. Okay, Now let's go and run this. Okay, and here at the end you will see the results. Okay, because we just created the replace null function. Now we are gonna apply this replace null function on our columns. Okay, we are gonna use a data frame and the column name. So let's go and run this. Okay, so now we just replace the null values of glucose. Now the see in the replace we want this is null dot sum. Okay, means now in the glucose column there are no null values. Okay, let's apply the same for blood pressure, skin thickness, insulin. Okay, then BMI, and lastly we can see the all the columns in one go. Okay, so here you will see that. Okay, now we have all the columns here and there are no null values. Okay, in the column. Now after this we can see the correlation matrix again, because now we just transform few data. Okay, because we just transform 0 by median value. So that's why first we have the this correlation map with this correlation values. Okay, now let's see the change. Okay, in the correlation map. Okay, now here you will see that there is small change in the BMI index and the skin thickness. Okay, because see in the BMI index 11 and in the skin thickness the 227 zero values are there. So as we change the as we replace this zero by median, so that's why here we will see some change in the correlation matrix. Okay, but again this 0.6 again we can say that this is a poor correlation. Okay, so when there is a poor correlation, so we can say that it's very much very close to a no correlation. Okay, we can say that the poor correlation. Okay, means it's not the it's not affecting our analysis. Okay, so that's why we can simply go for our analysis. Okay, so we can check the shape of our original data as well as our new data, which is NAND data, as we created this data. Okay, few step above. Okay, see the shape of both data frame is same. Okay, so now let's copy the data frame. Okay, which is NAND data frame. Okay, to apply the transformation. Okay, various analysis on the data. Okay, this is my column list. Okay, this see all the columns are there. Okay, and now you can, as we just change the df, just add this the store this copy of data frame as a dfs, so we can even go and see the shape. The shape is also same. Okay, and here we are gonna see the dist plot. Okay, which is nothing but the, you can say that the distribution plot. Okay, and distribution plot is again the very much similar for as the histogram, but here you can see that. Okay, and here we got the one warning, because in python is a open source and developers are updating python, they are finding out the errors. Okay, and they are updating pythons, so that's why here you can see that this is nothing but the future warning. This plot is a deprecated function. Okay, and will be removed in the future version. Okay, so we can even use displot, only they change instead of displot. Okay, dist plot, they just use dis plot. Okay, so that's why. Okay, we just go with the displot instead of dis plot. Okay, because this is the warning. Okay, not the error. So here we can just find out the skewness, kurtosis of our distribution of pregnancies, glucose, blood pressure, skin thickness. So now what is distribution and why to just find out this all these things? Okay, because when we say here, see, this is a positively skewed data. Okay, when we say this is a positively skewed data, which means that any positive skewed distribution is very much close to this density function. Okay, means we can relate this data to that distribution. Okay, and we know all the distribution. When we know all the distribution, we can simply just, instead of going into deep analysis, we can simply use their mean median mode of that distribution. Okay, to find out the mean median mode of the data, we can go for just skewness, kurtosis, and all the different analysis, as well as all the different hypothesis test. Okay, so it's very easy to analyze data when we know the distribution of the data. So see, this is the data. Okay, when we transform this data is very much look like a normal distribution. Then we can say that yes, we know the normal distribution. Normal distribution is a central distribution. Then we can easily apply several methods on this, because when we know the distribution, then it's very easy, okay, to handle the data. Like this, we just find out all the columns density or plot. Okay, see, and lastly we have the outcome. Okay, so outcome is nothing but the discrete column, okay, in terms of 0 and 1. So that's why it just gives a 2, it gave us a 2 bar. Okay, which is same as a count plot. Okay, now here you can see that, okay, here we are, here we did the one thing. Okay, we just extract the data and we build the histogram, okay, or this plot. Now here we are gonna split the data, okay, into class 0 and class 1. Okay, because this is a target 0 and this is a target 1, we split the data into two different classes, 0 and 1. And let's run this and see the output. Okay, again we got the same warning, okay, which is not important. Okay, but what important is the plots. Why? Because now we can again able to understand, we can able to visualize this data in terms of both classes. Now we can simply find out the best feature, which is the best features and which is the least important features. Okay, okay, so this is all about the pregnancies, glucose. Okay, and see, this is how we can just go and see the data. Okay, and see the distribution of two data, okay, from class 1 and class 0. So we can say that this is some few portion is overlapping, few portion is not overlapping. So if the data of glucose is somewhere here, so we can simply say this is from the class 1. Okay, yes or no? So this is the very easy part. Okay, but understanding this thing, okay, finding insights from the plot is very much important. Okay, and if you are able to find out the insight from the one plot, then it's very easy to build the model. Okay, and this is the another thing, if you don't want to go with this, okay, just the histogram, so you can the this plot you can see this. Okay, this is nothing but the histogram of the columns. Okay, see, I just extract this many columns, all the input columns, and see, I'm just creating hist. Okay, which is nothing but the histogram. From which library? From Pandas library. So which means that we can create plot, we can create data visualization from Pandas library too. So Pandas library is very much important for this. Okay, so to understand Pandas library, one thing is there, just go here and learn Pandas library. Okay, from here, it's very much important, because 80% of any data science project, 80% of time, okay, the data scientists just use for data cleaning, data pre-processing, for finalizing data. Okay, now that's the thing. And here we can see, now here we just fill all the missing values. Okay, and now here you can see the box plot. Okay, now this is a very big coding. Okay, you can optimize this coding too. Okay, so it again the totally depends on you. Okay, see, the colors are not important. Okay, so you can even go for without colors. The title is not important, so for title, for label, okay, it took the, like, it just increased the line. Okay, so see, for this is a irrelevant code. Okay, but to just beautifying it, okay, for the purpose of beautification, I just added this code. Okay, so then we can easily understand, yes, yes, this is the outcome. Okay, we just split the data into class 0 and class 1, and then we create the model. Okay, so see the number of pregnancies, okay, versus diabetes. Okay, so see number of pregnancies. So when we talk about the class 1, there is no outlier. Okay, and the range of class 1 is high, 0 to 17.5, but the range of class 0 is low. Okay, this is the normal patient's range, this is a diabetics patient range. Okay, now here you can see that this is another columns box plot, which is glucose. And see that, yes, there are outliers. Okay, there are outliers. So we can say that, yes, there are outliers in the glucose column. Okay, so that's why we use median. Yes or no? In the data we have outliers as well as the data is numeric, so that's why we just use median instead of mean for replacing nan values. Okay, so this is the thing. Okay, and from box plot you not only find out the outlier, see here, with just by creating outlier, okay, by one line of code, you can use a SNS, Seaborn library, or Matplotlib, or even Pandas library for creating box plot. But again, this is the extra thing, okay, to just add the colors in it and all the things. Okay, so this is up to you whether you have to go for a beautification or not. Okay, but if you go for a beautification, okay, where whether you have to explain this thing to someone else. Okay, if this is for the presentation purpose, then you can go and use this. Okay, otherwise for yourself only you can use one line of code for creating box plot. Okay, to understand the code in better way. Okay, so see here there are outliers. Now what is this? These lines are nothing but the minimum value and the maximum value. This line is nothing but the minimum value and the maximum value. Okay, yes, few of you may confuse, sir, this is outlier, so how this is minimum value? So this is a range, this is the normal range, actual range of this data. Okay, we have the total data 768 data points in our data. Okay, so how many are from class 0? Okay, for this glucose column, so in this glucose column, how many are from class 0? Those data's actual range is this, actual range is this. So I can say that, yes, this is the minimum and this is the maximum, and these are the outliers are the extreme data points. Okay, whether the data points in the lower extreme or the higher extreme. Okay, these lines are nothing but the outlier quartiles. This is the first quartile, means in this region from 60 to around 95, there is 25% of data, okay, lies in between this region. Okay, now this is the first quartile, 25th quartile. Okay, or you can also say that first quartile, this is the second quartile, this line, or you can say that the median is nothing but the middlemost value, means below this line 50% of data is there. above this line 50% of data is there. Okay, and here you can see that this is the upper quartile, 75% of the data, means below this line there is 75% of the data lies. Okay, and above this line only 25% of data is there. Okay, like this is the interpretation of data, and you can just find out very much different, uh, you can say that insight from the box plot. Okay, you can find out the skewness, okay, by comparing the these quartiles. Okay, you can find out the median, minimum value, maximum value, outliers. Okay, so a lot of things you can just find out. Okay, and if you wanted to find the outliers, okay, manually, then you can use this. Okay, you can use this thing. Okay, so when you have to find out the outlier from the data, then manually you can use this is a lower. Okay, uh, for lower part, okay, you can use q1 minus 1.5 multiply by iqr means q3 minus q1. Okay, and for upper region, okay, you can use q3 plus, means this is the third quartile, 1.5 multiply by iqr interquartile range. Okay, q3 minus q1. Okay, so you can use this to find out the outliers manually. Okay, so you can use this as a test as well. Okay, but we can test is the different thing. Okay, this is the one formula for just finding out the outlier in the data. Okay, so like this we can just find out all the box plot. Okay, you can explore this. Okay, you can go and you can just try to find the insight from this box plot, then you will understand. Okay, see, in each and every box plot there is an outlier. Okay, let's go and run this. See, here also there are outliers present. Okay, and for insulin as well, see the outliers. Now the box plot is very small and this is a one line box plot. Okay, means the range is very small and outliers are there. Okay, and here also you can see the outliers. Okay, BMI index and diabetes predictive function, here also you will see the outliers. So that's why we just go with the median. Okay, see, here also we have the outliers. Okay, now after these, okay, see, these are the box plot I just wanted to show you. Okay, because we use this box plot to find out, yes, is there any outlier or not, or any other information inside, you can find out this box plot. Okay, now we just finalize our data, yes or no, we just finalize our data. So after finalizing our data, now see, after finalizing our data, now we can here see that, okay, we can simply go for the model building part. Okay, and for model building part, okay, here we have so many different modules in the specific libraries. Okay, as we know, first we already imported these libraries. Okay, Pandas, NumPy, Seaborn, Matplotlib. Now for model building, okay, we want one library which is sklearn. Okay, which is sklearn. So see, now we have the data. Okay, and we are gonna apply some pre-processing on that. Okay, because we just clean the data. Okay, now we have to format our data. Okay, for model building part. Okay, for formatting this, okay, just because of that we are gonna use label encoder, one hot encoder. Okay, and again it depends on the data to data. Okay, then model selection. Okay, so for selecting models we are gonna import grid search CV, grid search cross validation. Okay, now these are the heavy words, but believe me guys, you will find these things very easy. Okay, you will find these things very easy. Now random forest regression. Okay, this is not the uh, you can say that the code here for this. Okay, you can even erase this because this is a random forest regressor. We are going to use this in tomorrow's session. Okay, classifier, random forest classifier from the ensemble, because this is a ensemble technique. Okay, explaining this random forest classifier. Okay, the now in the today's session I'm not going to explain this random forest classifier. Okay, it's math intuition. Okay, because our main purpose is to go and is to show you the end-to-end data science project. Okay, with deployment in Flask. Okay, so that's why. But for this, okay, you can go and you can search for this, you will understand, because it's very easy. In the name itself there is a random forest. Okay, so which means we are going to create multiple models. Okay, in this random forest. Okay, then linear discriminant analysis, then support vector classifier. This is nothing but the evaluation matrices: F1 score, ROC curve, precision recall curve, ROC EUC score, classification report, confusion matrix. Again, this is another, you can say that the gradient boosting classifier, again method, which is another method same as this random forest ensemble method, but the process is different. Okay, then again the F1 score, max scorer. Okay, the PCA, principal component analysis, to reduce the dimension of data. Okay, so see here in our data dimension is actually very small. Okay, but just to show you how you can use principal component analysis. Okay, for this I just added this here. Okay, and again the matrix. Okay, now let's go and run this first. Okay, done. After this let's copy our data frame. Okay, because we are going to just apply the transformation on the data. So for that, okay, so now here you can see that PCA x means the input columns. Okay, so that's why here I'm gonna drop the outcome column. Okay, so x means the input column, because total columns are 9. First 8 column are the input column, and last one is the outcome column. So I'm gonna create a model by using first 8 columns, not the last one. So that's why here just remove this outcome column. Okay, and here just use the sklearn dot pre-processing, which is a standard scalar. Okay, now the standard scalar transform the range of the data from any different range to -3 to +3. Okay, why we are doing this? Because let's say here, see in the description. Okay, see we have a description here. Okay, means a descriptive statistic is there. Okay, see the mean. Okay, the minimum value and the maximum value. So you can say that the mean of pregnancy is 3.84, glucose is 120. Okay, so can you see the difference? Okay, so at the time of model building, okay, it will affect the model, because so glucose has a high range from 0 to 199. So which means that at the time of model building, glucose just dominating column is just the dominating column. Okay, or is just having a high weightage for creating the model. So to avoid that part, okay, because we want the each column with this same weightage. Okay, we want each column with same weightage. So for that reason I'm gonna transform our data, okay, by using a standard scalar library, standard scalar method. And we are gonna import standard scalar from sklearn dot pre-processing module. So we just stored a standard scalar as the scalar. Okay, and here I'm gonna apply this fit transform method. Okay, because by using standard scalar, just we are fitting the standard scalar on the data and transforming it. So that's why fit transform. Okay, and storing it into the data frame. Okay, let's run this. Okay, and see the data. Okay, now this is my data frame. Okay, this is my data frame. Okay, so total we have 768 data points and the 8 columns, because we just drop one column, which is the outcome column. Okay, you can, instead of this, okay, instead of this, you can even go with the head method like this. Okay, so this is up to you. Okay, it's a alternative choice. Okay, and here I just created a data frame for this one column. Okay, because here we are gonna use this outcome column for model building. Okay, we transform the column, we just formatting the our column, which are input columns, and at the end of model building we are going to use these two columns, input and output columns, together to build the model. Okay, so this is the visualization of the principal component analysis, because here see, we are just applying the principal component analysis with two components only. Okay, we want two principal components only. PCA.fit transformation, we just fit the principal component analysis and transform data. Okay, again this is a data dimensional reduction technique. Okay, see in the correlation map, okay, we have some kind of correlation, but after using principal component analysis we transform data. Okay, we transform data from correlated data to uncorrelated data. Second thing is that here we have the 8 columns, 0 to 7, total 8 columns are there in input, but now we are merging this 8 column into 2 columns only, or you can say that the two principal components. Okay, so let's go and run this. Okay, and see the principal component, this is the first principal component and this is the second principal component. Okay, this is to just show you, okay, how you can use principal components. You can, now this is a only two principal component, you can even go for a 8 principal component as well. Okay, because principal component gives you a uncorrelated data, which is very much important. Okay, or even you can go ahead with this data as well. Okay, and here you can see that we have a diabetic outcome column, PCA1 and PCA2. Okay, so let's see the explain variation of each principal component. Okay, because we merge the column into only two principal components, so we have to check the how much information each principal component just take. Okay, so wait, yes, I am going to share the this code with you at the end of the session. Okay, what does one or two represent? In the outcome column, 1 is for the diabetic patients, 0 is for the non-diabetic patient. Okay, and here our aim is to build the classification model, because on the basis of historic data, this is the historic data. Okay, and we are using historic data to build the classification model to easily classify the diabetic patient and non-diabetic patient. Okay, so that's why instead of using, see, PCA1 and PCA2 are the two principal components. Okay, first we have the 8 columns. Okay, so here by using a principal component is a dimensionality reduction algorithm. We apply this algorithm on the data, and after applying this algorithm on the data, here we got the two principal component. These two principal component is again the linear combination of these columns. Okay, linear combination of this column. Okay, and behind this, okay, we apply orthogonal transformation. Okay, through the PCA. principal component analysis. Okay, and then we got these two principal components, PCA1 and PCA2. These are the two columns or two principal components, PCA1, PCA2. Understood? And this is the explain variance of each principal component. Okay, because here we just use only two principal components. Okay, so that's why first principal component gives a around 30% explain variation of overall data. Okay, means instead of this 8 column, okay, if we go with this only 2 column, which means that around 50% of information we have of our data. Okay, so yes, there is a 50% loss. Okay, so you can go ahead with the 8 principal component as well. Okay, this is just example to show you how we can use principal component. Okay, and how we can find the explain variation ratio. Okay, this is the scatter plot. Okay, now this is the normal scatter plot of two principal component. Okay, now here you can see that, okay, we just apply the principal component. Okay, to just show you how we just apply principal component on the data. Okay, now let's apply another algorithm of the unsupervised learning, which is TSNE. Okay, long form of this is nothing but the T distributed stochastic neighbor embedding. Okay, again this is a very complex name, but this is a, you can say that the statistical method. Okay, and with this, okay, you can just go and you can visualize high dimensional data. Okay, so let's go and copy the data. Okay, and let's see the data. Okay, again the same data we are going to use. Okay, here in the Y we are just saying that yes, this is output data. Most of the time input data is X, output data is Y. Okay, so here see, this is the Y data and this is the DFTSNE, which means that this is the X data. Okay, and here this is how the data looks like. We just remove the last column, which is the output column. Okay, we store it as a Y. Okay, now here we are just applying the manifold cross validation, which is a TSNA. Okay, so these are the different methods. Okay, so it's totally up to you to use these methods or not. Okay, when do we new when when do we need to use principal component analysis? So listen, when we have a large columns, when we have a large amount of data, huge amount of data, and we can't do analysis in our system. Okay, because yes, there are some limits, okay, on our system. Okay, because RAM is specific, operating system is specific. Okay, so for that reason, if we have a huge amount of data, so to reduce the dimensity of the data, let's say we have 1000 column, 1000 rows. So let me consider this is a used data. It's actually, this is not the used data, but consider this is a used data. So by using principal component analysis, you can transform this 1000 cross 1000 data into 1000 cross 10, means you just merge the column. Okay, by using principal component analysis, you can reduce the dimension of the data, you can reduce the column numbers. Okay, so that's the power of principal component. And this is a TSNE. Okay, T distributed stochastic neighbor embedding. Okay, and after, again the, which is again the very much similar to the principal component analysis, and here you can see the plot. Okay, now can you see the diabetic and non-diabetic patient very separately? See, most of the non-diabetic patients are this, and no, the diabetic patients are this. Okay, over here, yes, there are some intersections. Okay, like this, see, few data points are blue and few are orange. Okay, because this is a real life. Okay, and in real life there must be a error. Okay, in real life we say yes, 100% accuracy is there. Okay, so that's not the real life. in real life error is always there. Okay, so that's the point. So that's why you see, and this visualization you can imagine, okay, with the tsne you can easily separate this. Okay, but this is a unsupervised learning. Okay, so the purpose of this is different. Okay, so we are not going to use this model for the in model deployment, but now we create the models. Okay, now we create the models. So first thing is that, okay, to check the head, okay, to find out the columns, because here we should know the column names, because it's very important, okay, for our analysis, like what are the columns we should want in our further analysis for model building part. Okay, and now from here we are going to apply the different models. Okay, so this is a, we just copy the data, okay, and see the y-x, we just split the data into x and y, input and output data. X is input data, y is output data. Okay, and these are the column names we have. And now here you can see that I'm gonna split the data into two different data set. First one is a train, second one is a test. Why? Because at the time of model building, okay, after building the model, how we say that this particular model is good, this model is not good. So for that reason, we are gonna build the model on the train data, and we are gonna split the model on the test data. Okay, we are gonna find out the accuracy of the model by using a test data. Okay, so see, this is a 4 data set we just created, because now we have the 2 data set, okay, x and y, and again we have to split this 2 data set into 2 different data set. Okay, so we just split the data set into one data set into 2, another one data set into 2. Okay, so total 4 data set. And this this is very much important. Okay, x train, x test, y train, and y test. So order is very much important for this. So here train test split we just apply on the x and y input output data, and here I want the test size should be 20% of overall data in the test data. Okay, so indirectly train side would be 80% of overall data. Okay, random state is 20, which means, okay, we are not repeating this random sampling. Okay, because for splitting the data we are going to use sampling method. Okay, so here random state is 20, which means each and every time when we are splitting this data, when we are running this particular line of cell, we want the same data points into the train as well as the test. Okay, as we got in previous part. Okay, and stratified is equal to yes, y, which means that yes, instead of simple random sampling, here we are going to use stratified random sampling. Okay, because of this visualization. Okay, this visualization. Okay, now stratify random sampling, simple random sampling is again the part of statistics. So that's why statistics is very much important for any data science project. Okay, so you can explore this. Okay, stratify random sampling, what is simple random sampling. Okay, and see, okay, as we have the x train y train data, so let's apply the transformation on the data set, because we already use apply fit transformation. So that's why no need to just go with this. So just fit on the train. Okay, and apply transform. Okay, so see, this is a std and std data transform. So we just first fit the train data, okay, on by using standard scalar method, and here we just use the standard scalar data, okay, as the pickle file, okay, into the deployment part as well. Okay, we'll talk about this in the deployment part. Okay, after transforming this train and test, okay, because we have to transform both the data, because we have to apply models on this data, so that's why. Okay, and this is the data frame. Okay, we just transform into data frame and see the how the data frame looks like. Okay, and this is the x text. Okay, this is the test data. Okay, in the test we have 154 rows and 8 columns are there. Okay, in the X test. Now here you can see that. Okay, now first model we are going to apply on this data is nothing but the logistic regression. Okay, and if you know what logistic regression is, okay, and why we use logistic regression, okay, then the first thing is that logistic regression is very easy. Okay, second thing is that it's a very basic method of classification. We are going to use logistic regression for classification only, not for regression. Okay, not for regression. Okay, and here you can see that. Okay, we are after just importing the logistic regression from sklearn.linear model. Okay, here we are just using logistic regression. Again, the random state equal to 20 and penalties. This is a regularization parameter, which is a L2 parameter. Okay, again there is some depth of there is some, you can say that, the statistical intuition behind this L2 uh, application. Okay, but here just understand this thing. Here we are just applying the logistic regression on the data. Here we just build the model by fitting the logistic regression on the trained data, and lastly we'll go and predict the on the test data. Okay, and lastly here you can see the we are gonna use the score is nothing but the accuracy of the data. Okay, so the accuracy of the logistic regression is the 83%. Okay, now after this, here you can see that again we are going to split the data. Okay, because each and every time, okay, either you can use the same train test data, okay, or you can go and run this each and every time. Okay, so it totally depends on you. Okay, because if you change this, then definitely, okay, you will get the different train and test data. Okay, now here instead of minimum max scalar, okay, I'm using the uh, instead of this where standard scalar, I'm using the minimum max scalar. What is the difference between standard scalar and minimum max scalar? The minimum max scalar gives you the values in the range 0 and 1, but the standard scalar gives you a value in the range -3 to +3. Okay, so that's the difference between the standard scalar and the minimum max transformation. Again, the all the remaining steps are the same. Okay, so let's go and run. Okay, and again here you can see that this is a X-test data. Okay, and again here you can see I'm using logistic regression. Why? Because try to understand, in first case, okay, I use standard scalar, another different transformation, means my data is different. Okay, see the few data points are minus, few plus. Okay, but after using the minimum max scalar, see there is no negative data, and the each and every data point is between 0 and 1. Okay, so that's why again I am going to use logistic regression to see the accuracy, whether it increase or not. Accuracy is decreased a bit. Okay, the first accuracy was 83% by using standard scalar, but now 82% accuracy is there. Okay, so again, okay, just finding the model is very much important, finding the best model. Okay, but for that you have to do so much the analysis. Okay, you have to just you you have to go with different trials and error methods. Okay, you have to apply different data transformation methods. Okay, you have to use a different random state parameter values. Okay, it totally depends on you. Okay, if you're curious to find the best model, then definitely you can able to find the best model. Okay, so it totally depends on the number of hours you are using for just finding out the best model. Okay, and this is a, you can say that this is a matplotlib again, and here we are importing pyplot. and here we are just creating the histogram. Okay, so basically here you can see that, okay, the histogram. Okay, because first thing is that, okay, now we just apply the logistic regression. Okay, and by just applying the logistic regression, okay, we have the data. Okay, we have the data, we didn't change the data. Okay, we just change the data for logistic regression for building the model only, and this is my original data. So that's why each and every time here I just use to copy the data. Okay, I just use to copy the data. Now after this, okay, now let's go for the another, you can say that the another model building part. Okay, but now here you can see that, okay, we are just again doing the different transformation. Okay, we are splitting the data into extend y train. Okay, so now there is no need to see the train test. Okay, type of this all. Okay, and here you can see that first BMI, pressure, okay, blood pressure, glucose values. Okay, we just selected the three columns. Okay, and again here we are selecting the another remaining five columns. Why? Because can you see here, I am going to apply the standardization, okay, standard scalar on these three columns and the normalization on these five columns. Okay, why? Because it is totally up to us. If this gives a better accuracy, so that would be great. So that's why I'm going to just check this. Okay, so it is totally depends on you. Okay, it is totally depends on you whether you have to apply this many transformation or not. Okay, so this is the thing. Okay, we just transform this, we apply transformation standard scalar on these three columns, and we apply minimum max scalar transformation on these five columns. Okay, see the difference. Okay, now let's concatenate this by using pandas library. Okay, the standard and normalization axis equal to 1, which means that merge these two column by using column. Okay, column, not the rows. Axis equal to 1 means column wise merge. Okay, so see after concatenate, okay, let's see the head. Okay, and you can even go and see the test values. Okay, this is for you too. Okay, and again use the same logistic regression. Okay, so for one logistic regression, how many times we are transforming our data, how many times we are applying transformation on the data. See, so you can use different transformation as well. Okay, 0.82, again the accuracy is not increasing. Okay, now we'll go with the default one. Okay, or the first one which we used. Okay, so just split the data into train and test. Okay, and the standard scalar and our logistic regression, and see we got the 83% accuracy. 83% accuracy for the logistic regression is, you can say that again the good one. Okay, okay, so see after the logistic regression, after so many transformation, okay, applied on the logistic regression. Okay, now we are going to use another algorithm of machine learning, which is k neighbors classifier. Okay, which is the k nearest neighbors classifier. Okay, so we are going to import k neighbors classifier by using sklearn.neighbors. Okay, this is the test score, train scores, and we are just created we just created the for loop. Okay, for each k value from 5 to 15. Okay, from 5 to 15, not 15, it's excluded 5 to 14. Okay, so let's go and run. Okay, and see the best accuracy. Okay, so the maximum accuracy for the train is 85%. For what? K equal to 11. Okay, and the maximum test accuracy is 87%. For what? K equal to 13. Okay, so whether you go with the k equal to 11 or whether you go with the k equal to 13, okay, or see, this is the test accuracy. So if the test accuracy is high, which means model is able to predict new data correctly. Okay, so we can go ahead with the this accuracy, which is 87%. Okay, now this is another the support vector machine algorithm. Now this is, you can say that the another most popular algorithms, okay, of machine learning. Okay, now this is based on the support vectors. Okay, and also it uses some kernel methods. Okay, so that's why it is again the very popular one. Okay, and it just transform data dimensity, okay, from 2 to 3 to classifying the data. Okay, that's important. And see, we just apply the support vector classifier and we are fitting this classifier on the trained data and we are making the prediction on test data. Okay, and we are just finding out the score accuracy. Okay, and see the accuracy is around 88%. Okay, so as you are changing the train and test data, okay, so then you will get, okay, you will change the accuracy too. Okay, now this is extrain, okay, the shape of this extrain. And now after this, okay, here in the random forest as well as for the extreme gradient boosting classifier as well, you can use a grid search cross validation, okay, for finding out the best model of random forest. So see, in this line of, in this cell, okay, I am going to use one parameter name n estimator, maximum depth, maximum features. Okay, and for n estimator, okay, I just added three different values for maximum depth, three different values for maximum feature, five different values. Okay, so now I'm gonna create a model, okay, of this each and every parameter, okay, and combination of parameter too. Okay, so that's the power of grid search cross validation. Okay, and see, first I'm gonna create a model which is with n estimator value 50, maximum depth value 3, and maximum features value 1. Likewise, I'm gonna just create every combination of these parameters. Okay, the model of every combination of this parameter. Okay, and lastly here you can see that here we are just using this classifier. Okay, and this is the parameter grids, we are applying it. Okay, and cross validation 5, which means that the split our data into 5 different part. Okay, and use every 4 different part for each analysis, for each model building, and just find out the accuracy. Okay, and which part gives you highest accuracy, use that part. Okay, so see, now it is taking some bit time. Okay, because see, here we are not creating one model, we are creating multiple model and we are finding out the best model from multiple models. Okay, so see the best parameters: maximum depth equal to 7, maximum features equal to 3, and n estimator equal to 100. And we got the accuracy which is 88%. Okay, which is again you can say that the good one. Okay, and you can go and import accuracy score from the matrix. Okay, and now I'm going to use these three, okay, parameters, okay, to build the model. Okay, because after finding the best model, I just have to find out the the model. Okay, because I am going to use this model. Okay, I am going to use this model for deployment. Okay, if this model is better. Okay, so see here, test accuracy is 89%. Okay, so test accuracy is around 89.6%. Okay, and see the confusion matrix. Okay, now in the name itself, confusion matrix. Okay, now because you have to understand this confusion matrix, okay, to see twice or thrice, then you will understand this. Okay, because first time, okay, here you can see that this is the first value. Okay, so in the test data total we have, I think, 158 data points are there. Okay, and see here, first this is the 92 is nothing but the total number of, this is a correct negative prediction. Okay, or you can say that the number of data points from class 0 predicted as a class 0. Okay, this is nothing but the number of data points from class 1 predicted as a class 1. This is a true positive value. Okay, and these two off diagonal values are nothing but the incorrect prediction. 8 8 total 16 incorrect predictions are there. Okay, this is nothing but the false positive, which means that, okay, the total number of data points, okay, are from class 1. 8 data points are from class 1 but predicted as a class 0. Okay, so likewise this is a vice versa. Okay, number 8 data points are from class 1 predicted as a class 0. Okay, like this. So in first, okay, you will never understand this. Okay, but you have to repeat this. You have to try to understand this. In the case of true positive, this is a true negative, this is a true positive, this is a false negative, this is a false positive. Okay, and then understand these things. Okay, and after this, okay, here gradient boosting classifier, it will take more than 10 minutes, okay, to run. Okay, because see here, now I'm using four different parameters. Okay, four different parameters with different values. Okay, three, four values, and here see around six values. Okay, seven values total. So which means that, okay, it will create the lot of models, and random forest parallelly create the model, but gradient boosting sequentially create the model one after another. So that's the drawback of gradient boosting, and it will take so much time. Okay, and again, gradient boosting will need a lot of hyperparameter tuning part. Okay, so this is nothing but the hyperparameter tuning. We are just finding out the best parameter for our model. Okay, but definitely you will get the best result from this gradient boosting classifier. Okay, so this is the thing. Okay, and here we got the best parameters. Okay, so see, after model hyperparameter tuning, here we got the best parameter. Okay, this is not only the four parameters, we have so many different parameters. Okay, around 20 parameters are there for the gradient boosting. Okay, so you have to just tune the all the 20 parameters, then definitely you will get the best model of gradient boosting for your data, because for each and every data your model will be different. Okay, your accuracy will be different. Okay, so let's go and run this. Okay, so see, now here we got the 87.7%. Okay, which is, so this is quite good. Okay, and after this, okay, I'm gonna create the deep learning model. Okay, because this is not just the machine learning. Okay, in the machine learning we have one subset which is deep learning, so that's why I will show you how to create a deep learning model. Okay, and this deep learning model is a very simple model. Okay, but okay, if you have to create deep learning model, before that you have to run this line of code first. Pip install keras and pip install tensorflow, because these two libraries are very much important for the deep learning task. Okay, just go and remove this and run this, just go and remove this and run this. Okay, because these two are the, like, I already did this, so that's why no need to run again. Okay, and this library is around the size of this library is around 450 MBs, so that's why it will take some time. Okay, depending upon your speed of internet. Okay, so let me comment out this. Okay, and let me import this tensorflow import keras and tensorflow.keras for layers. Okay, like after this, okay, after this we'll just go and we'll just save the model, okay, by using pickle library. Okay, I think we are running out of the time, so we can do one thing. We can just go and we can run this all the remaining code into like in the tomorrow session, and then we'll go for the model deployment part. Okay, that would be better. Okay,